Hey everyone, we have a senior engineer from Consensus Diligence, which focuses on audits, and they'll be doing a talk on automated testing of smart contract systems. Would you mind introducing yourself while the audience just confirms that they can hear you?
Sure, yeah, thanks. I'm Valentin, and I'm a researcher at Consensus, in particular at Diligence, which, as mentioned, like we're mostly focused on audits, but we also develop tools to help developers of smart contracts build more secure contract systems.
Cool, so everyone can hear you. You can hop in and continue.
Okay, great. So yeah, thanks for the introduction. So let me talk about some of the challenges that we currently see when doing quality assurance of smart contracts. As you might have noticed, these systems are getting bigger and more complex. And in particular, they start having a lot of different dependencies, for instance, on tokens, lending pools, and other more other components that people use to build these systems. So that makes it pretty difficult to actually do manual testing of these systems, and it also makes it quite time-consuming. So in order to kind of help with that, automated testing is a great way to start. And this is also a technique known as fuzzing. So in the rest of the talk, I will talk a lot about fuzzing, but basically this is an automated way to generate test cases, and in particular in the context of smart contracts, it's to generate sequences of transactions automatically that then explore the smart contract that you're testing. And the goal behind automated testing or fuzzing is to cover the code, and in particular also to ideally find corner cases that maybe as a developer yourself you've missed, you've overlooked when writing your own test cases. Second, of course, it's to find bugs. And third, which is also very important, I think, is that by following these best practices, like running a fuzzer or running some automated tools, doing audits and so on, you actually increase trust in the correctness of the code that you're deploying. And this is both very valuable to you, but also to your users. And of course, finally, you want to catch all those bugs before the bad guys do, right? So what can we actually test with these fuzzers? What are they good for? Well, the first category is these common issues like arithmetic overflow, reentrancy. I'm sure you've heard about some of them when reading about certain hacks or issues that people found in existing contracts. But then there's also a second category, which is maybe even a bit more important, and that's what we call custom correctness and security issues. So what does this mean? For instance, an example would be that you want to make sure that if you have a token, that you want to make sure that the total supply is actually equal to the sum of all the user balances. And this is a more complex property that maybe you would write a test case for. And I'll explain a bit how these type of properties can also be tested automatically using fuzzers. And the thing about these custom properties is that they often are most easy to identify by a developer or by an auditor by looking at the system. And they're actually often specific to a given system. So it's not like one size fits all. So you have to actually look at the system and try to understand what the system is supposed to do to find these properties. So I mentioned that there's a lot of tools out there that are able to help you when developing smart contracts. And I would say there's different levels. So on the first level, I call them all-in-one tools. So these are basically tools that are very automatic, could be linters, could be other tools. They catch a lot of common issues in smart contracts, which is great. However, the support for checking such custom properties is not that exhaustive. I mean, they are able to check certain simple properties, but typically not very complex ones. And typically, they target a single contract at a time. So an example of such a system or such a tool would be Mythx. It's a tool we're developing within Diligence. If you haven't tried it out, go to mythx.io and give it a try. However, like after you've used these sort of level 1 tools, you might realize that maybe there's still some things you haven't really explored properly. Some properties of your system that you might want to invest more time in making sure that they actually hold. And for me, the second level essentially is to use such targeted fuzzing campaigns to actually try to check certain properties of your system more thoroughly. The first step in doing this is to identify these properties. And then to run a fuzzer, maybe for hours, days, could be even weeks if you wanted to. And an example of such a fuzzer is the Harvey fuzzer we've been developing at Diligence. Why would you want to use Harvey? So first thing is Harvey actually does not report any spurious violations of a property. So if you tell it, like, check this property, it should not report any spurious violations. In particular, it runs each test case that it generates for such a violation and runs it on the Go Ethereum EVM implementation. So it's not running some variant of the EVM. It's actually running one of the two most used implementations. In addition, it allows you to analyze systems of contracts, unlike maybe other tools I mentioned earlier that mostly focus on a single contract. And it's very robust. We've been developing it since September 2017. It was acquired by Consensus in 2018. And then we've integrated into our Mythx platform from the beginning. So it's one of the tools that's being used in the Mythx platform. And it actually integrates a lot of different fuzzing techniques that we developed in collaboration with Maria Christakis from the Max Planck Institute for Software Systems. So maybe before we dive more into how to run these custom fuzzing campaigns, let's look at how Harvey is used in the Mythx platform. So one of the nice things about Mythx is that it actually supports different types of analysis. So we have a lightweight static analysis tool that provides some that detects some issues on the source code and also does linting. But then we also have two tools that focus more on test case generation. So in particular, Mithril is one of the tools that you might be familiar with. It's doing symbolic execution. And then there's Harvey, which is doing Greybox fuzzing. I'll explain a bit later on what Greybox fuzzing is and how it's different from other types of fuzzing. And as I mentioned earlier, all these tools in this particular deployment, they actually focus on individual contracts. And it supports 3 modes. A quick mode that is like usually useful if you're running it in some, let's say, an IDE, or you just want to check after you've built your contract if there's anything that might go wrong. But then there's also a longer mode. We refer to it as standard. And then there's what we call deep, which is 45 minutes. But now, earlier I said you might run a fuzzer for much longer. And that's when it's good to run a standalone tool. In this case, I'm talking about Harvey, because it provides a more flexible API than the current Mythx API. So you can pick how long you want to run it. You can set up your contracts much more. You have much more flexibility in how you set up the contracts that you want to explore. So in particular, it's more designed for power users like auditors or like developers that are very advanced. But it supports a lot of cool things that I'm just going to mention a few of them here. As I said, it supports analysis of systems of contracts. It can also analyze several contracts under test, so several contracts that will be fuzzed at the same time. It also allows to interact with an existing running Ethereum node, like one you might use during development. And it allows you to run long-running campaigns, like 24 hours or more. And you can also access the results all the time while it's running. So that's great to see how things are going, whether you're finding any interesting issues on the fly. So in the following, I will quickly give you a little bit of insight into how we are currently using Harvey during the audit workflow. But some of these things also could be used in development. So the first thing maybe that should be explained a bit is how do you actually identify these properties that I was talking about. So one of the things about these properties is that typically they describe some sort of core functionality of your system. An example would be when a user deposits an amount of assets, then something happens, right? So some effect, there's some effect when the user deposits assets. Another way to think about how you can find these properties is to think about what should never happen in the system and then essentially negate it, right? So an example would be an attacker should never be able to access some sensitive part of the code. And then the property would be, that the attacker can access it. And if you find a violation of this property, then, or you find a case, and then you found an issue, right? The next advice would be to think about whether certain states are actually feasible, can be reached during the execution of the smart contract. An example for this would be, is it possible to preserve a negative balance for some user, right? And then write a property that checks that this is never the case. And if you do find something, you just confirm that it's actually possible. So how can we express these properties? So the most basic approach, which you can already use right now in Mythx, if you want to, is to add such assertions in your code manually. And then the tools will already try to violate these assertions, and they will give you test cases when they do. A more advanced approach that we're currently kind of developing and improving is to write formal specifications using our Mythx specification language. And examples of such specifications would be contract invariants, post conditions for functions, and a bunch more. We use a tool called Scribble to actually then instrument the code using those annotations. And this happens automatically. And yeah, we'll soon share some more details about this tool and how it actually works under the hood. So now, once you have these properties, how do you set up a fuzzing campaign? So often what we do is we actually use existing deployment scripts that people might have been developing to deploy their contracts to some testnet. And often we actually extend them a little bit to maximize the coverage that is achieved by the fuzzer. For instance, you might want to think about what users need for using the system. For instance, if your system requires users to have tokens of a certain type, maybe you need to actually distribute them to certain users that the system knows about before you can run the fuzzer. Another thing is that you might want to identify which contracts are sort of under test, which ones are the contracts that you care about most. And those will be the ones that the fuzzer directly invokes during the fuzzing campaign. So after you run a fuzzer, what kind of results do you get? Well, one thing is that you get some issues, for example, an overflow or property violation. And all these issues, they come with a sequence of transactions that you can actually look at or debug to understand how the issue was found. You can also get a test suite from Harvey or coverage metrics that help you determine how well the contract was covered. We're also working on estimating, giving you some number for the residual risk that maybe some issue was not found by Harvey. But this is still work in progress. And it's a very difficult and challenging topic. These reports or these results can help to complement an audit report. So for instance, typically what we do is we describe how we set up the contracts and which contracts we selected to fuzz. We also describe usually what properties we checked and whether any violations were found. And finally, you might also get some coverage numbers. For instance, you can see a graph over time, the number of instructions that were covered by Harvey here. And as you can see, they flatten out after a while, and this is usually a good indication that you actually explored the system fairly thoroughly. So now let's look at what Harvey is doing under the hood. I'll keep it sort of high level, but I just want to give you a little bit an idea of what is going on behind the scenes. So first, what is Greybox fuzzing? I mentioned this earlier. So for fuzzing, there's typically two extremes. There's black box and white box fuzzing. Black box is fuzzing that doesn't use any sort of feedback. It just generates randomly inputs and tries to find bugs this way. On the other end, there's white box fuzzing, which is also known as symbolic execution, which actually uses a constraint solver to generate new test cases that follow a certain path through your program or through your contract. And Greybox fuzzing is sort of in the middle. So in particular, it runs concrete inputs and not symbolic inputs. But it uses some sort of lightweight feedback to guide the fuzzer. And usually this is feedback about coverage. For instance, the fuzzer will know if it covered a new path through your code. But it does not use any constraint solving. So that makes it very quick. And usually fuzzers generate hundreds or thousands of inputs per second. So just to explain a little bit more about how this works, you can see the algorithm for Greybox fuzzing here. So usually you start out with a seed input that you run, and this populates a queue of inputs that you keep during the fuzzing campaign. And until the fuzzer is interrupted or stopped, you keep selecting new inputs from this queue and then assigning so-called energy to them. And energy here just means how often are you going to fuzz this input to get a new input f. And then what the fuzzer will do is it will run the new input f on the program and get a path ID. And this is just essentially a hash. And using this hash, you can determine if you found a new path through the program. And if so, that's great. That's what you want to do. You want to explore as many paths as possible. Right? So you're going to add it to your queue, and yeah, that's pretty much what happens, right? So you select the new input and you fuzz it again until you find new coverage. So now, after explaining this a bit, let's look at how these inputs, or what these inputs look like that Harvey generates. So on a high level, each input has an initial state, and this is usually the state in which the system was deployed. So it has a bunch of users, it has a bunch of contract accounts with balances and persistent state. And the second component is a non-empty sequence of transactions. So these are invocations of a contract under test. And this is what Harvey fuzzes. Each such transaction also includes block information, for instance, block time and block numbers. And that allows the fuzzer to essentially kind of move forward and backwards in time as it wants. And this is great for fuzzing systems that cover a long time span, for instance. If you're taking a loan for, I don't know, a month, then that's quite a long time. And the fuzzer can actually explore this very easily. It doesn't have to wait for a month. So that allows the fuzzer to reach fairly deep states of the contract that require many transactions to be sent. Another interesting thing is that the fuzzer actually doesn't need an ABI to know which functions are available. It just figures it out itself. So it just sends some sort of raw transactions to the contract. So based on this description, it sounds like fuzzing is pretty simple, but actually making fuzzing efficient is very challenging. And Harvey incorporates a lot of novel fuzzing techniques, and we're continuously doing research to improve the effectiveness of our tools. So here, just to bring up one of the challenges that we faced, is the challenge of kind of having these narrow checks, like to actually reach this point in the program, you would almost never hit this point if you were just randomly mutating the inputs. And we've developed a technique which we refer to as input prediction that allows us to do this much more quickly within just a few inputs. And the key idea here is to make Greybox fuzzing more wide, so to say, by adding additional feedback that is collected. In particular, what we record is sort of how far, for each branch, how far we are from actually flipping the branch. And we use this to suggest new inputs. And here, this is what we refer to as branch distance, basically how far we are from flipping the branch to the other side. Another example of such a challenge would be sort of these deep vulnerabilities that require many transactions. So for instance, in order to violate this assertion here, you would need to call several functions of this contract. And we developed a new technique, which we call demand-driven fuzzing, to make this easier. Again, here the key idea is to actually avoid fuzzing long transactions sequences because it's expensive. You have more inputs to fuzz. It takes longer to execute each sequence. And the number of paths actually grows exponentially the more transactions you consider. So the idea here is to avoid this as much as possible unless you know that it actually improves coverage. So how can you actually run Harvey? So the first way to do this is to actually use our Mythx service, which, as I mentioned, includes Harvey as one of the tools that we use in the background. The other way to at least leverage Harvey is to actually talk to us about our custom property verification services. And we actually have quite a few clients that are already using this to analyze their systems. So to summarize, I gave you a quick overview of Harvey, our in-house fuzzer for smart contracts, and how to use it to check custom properties of complex contract systems. If you want to know more, please check out some of our blog posts or papers for more details. Thanks. Are there any questions?
Cool. So I think there's one question in Ask a Question. Did you have a chance to answer that?
Sorry, I didn't see that. Okay, yes. I actually am not familiar with this. So this is this a special? I mean, I'm familiar with Biddler. Is this a special? But I'm not sure what. Actually, maybe it's just what I am familiar with. Yeah. Okay. I guess. So yeah, I guess the level that this fits into is not even. I mean, it's not. Well, the way I understand Biddler, it's more like Truffle or one of the tools that would help you to actually compile the contracts, deploy them, and so on, run your test suites. And so in that sense, I would consider it like level 0 or something, right? Where it's sort of already part of what people use to build their contracts. So when I refer to a level 1, I'm talking more about tools that go beyond like what a compiler would produce. So tools like Mythrill or Mythx or others. That Slither is also another tool that you might have heard of. There's a question about a dev certificate from Consensus. I'm actually not that familiar. I think we have some programs for developers, but I'm actually not probably the best person to answer that question.
Awesome. So I think we're out of time. Do you have any last words?
No, it was great being here. And if you have any questions afterwards, just feel free to contact me. But thanks for giving me the chance to talk to you guys.
Yeah, thank you. All right, we're going to transition to our next session now.